In question 6, functions f and g are both defined for x as an element of real number and are given by f of x, x squared minus 2x plus 5, and g of x, x squared plus 4x plus 13. In part A, we have to first express f of x and g of x in the complete square form, and then we have to express g of x in the form f of x plus p plus q, where p and q are constants. Now to express the function in the complete square form, so as f of x is x squared minus 2x plus 5, using the complete square method, so first we'll write x squared minus 2x in the brackets plus 5. Now taking half of b squared, so as b is minus 2, so we'll add x squared minus 2x, and half of b will be plus 1. So we'll add 1 squared in the bracket, and as we are adding 1 squared, so we'll subtract 1 squared as well. So this will be 1 squared plus 5. Simplifying this, we'll get f of x that will be equals to, so this will factorize and this will become x minus 1 whole squared, and minus 1 plus 5 will be equals to plus 4. Completing the square for g of x. So g of x is x squared plus 4x plus 13. Writing x squared plus 4x in the bracket first and 13 outside the bracket. Now taking half of b, so in this case, b is 4, so half of b will be 2. So adding 2 squared in the bracket, so that will become x squared plus 4x plus 2 whole squared. And then as we're adding, so we'll have to subtract 2 squared outside the bracket as well. Simplifying this, so g of x will be equals to, so this will become x plus 2 whole squared, and this will be minus 4 plus 13, which is positive 9. Now we have to express g of x in the form f of x plus p plus q. Basically, this means that we have to write this function f of x in such a way that when we add plus p to x value and plus q outside the bracket or to the whole function, we should be able to get the function g. Now, as the function f of x was x minus 1 whole squared, and for g of x, we need a plus 2. So from minus 1 to make it a plus 2, we'll have to add 3 to the x value. So for the function f of x to become from minus 1, this x value has to become plus 2. So we'll have to add a 3. So this will become f of x plus 3. And this was a plus 4 up here for the function f of x, and we need a plus 9. So we'll have to add a plus 5 to the function. So that will become a plus 9. So we can now write it as the function f of x will now become x minus 1. We are adding plus 3, so this will become a plus 3 whole squared, and we are adding 5, so this will be plus 5 plus 9. If we simplify this, this will become x plus 2 whole squared, and so this was a plus 4 up here for function f of x. So 5 plus 4 will become a 9. So we now know that the values of p should be equals to positive 3, and q will be equals to positive 5. So we'll have to write the function f of x plus p plus q as f of x plus 3 plus 5. In part B, it says describe fully the transformation that maps f of x onto the graph of g of x. Now we did in part A that we added positive 3 to the x value and 5 to the whole function. So basically, when we are adding values to the x value and to the whole function, it means there's a translation. So in the first step, we'll write this will be a translation. If you're adding a number to x, so that will mean a translation in the negative x direction. So that will become a minus 3. And as we are adding 5 to the whole function, so that will be a plus 5 in the y direction. So it will be a translation, and the vector will be minus 3 and 5.